So we're going to end with a little bit of talk about radicals, or you probably know them as roots, right? There's a lot of different kinds, but we call them radicals. What this says here is square root of 81, and we need to figure out what is the square root of 81. Here, the question we have to ask is, what number, if I squared it, would equal 81? And whatever the answer is, that'll be the square root of 81. Of course, we think 9 squared is 81, right? So we say that the answer is 9. If we have the square root of negative 81, we should be asking what number squared will equal negative 81? Well, most people are going to say that it's negative 9. But is negative 9 squared equal to negative 81? It is not, right? Because negative 9 times negative 9 is actually equal to positive 81. Now, can you think of any number, right, that when you square it, you get negative 81? You shouldn't be able to. This is actually undefined. There is no number that if we square it, we equal negative 81. Now here, we pronounce this here the cube root of 27. You see the little 3 there, the cube root of 27. With this number here, this is called the index, first of all, that 3. It's called the index. What we ask here is, what number cubed equals 27? Well, we need to do a little bit of trial and error, but you will see eventually that it's 3 to the third power is 27. So we say that the cube root of 27 is 3. Now here, same thing, we should say what number cubed equals negative 27? Well, you might think, again, just like they're up there, since this is negative 27, that was 27, maybe it's negative 3. Well, let's check. Negative 3 times negative 3 times negative 3. That's what it means to do to the third power. Negative 3 times negative 3 is positive 9. And then positive 9 times negative 3 is negative 27. So this actually works. We actually can say that the cube root of negative 27 is negative 3. Now this is the fourth root of 81. We have to ask ourselves what to the fourth power equals 81. And it just so happens that it's 3. You have to do some, calculating with that. 3 to the fourth power actually is 81. What about in this case? What number to the fourth power is negative 81? Would it be negative 3? Well, let's check. Negative 3 times negative 3 times negative 3 times negative 3. That's what it means to do to the fourth power. Let's check. Well, I'm just noticing that both of these multiply to be 9. And then these two will also multiply to be positive 9. And 9 times 9 is 81, not negative 81. It just so happens that this one right here, we can't think of a number, so we say it's undefined. Okay, in general, we can do the root of a negative number as long as it's an odd root. Okay, we could do an odd root of a negative number, but if it's an even root, such as fourth root or a square root really means there's a 2 there. If it's an even root, we cannot do an even root of a negative number. What about a fraction? You have an idea about what this would be? Square root of 1/9? Or what about the square root of 4/9? The way that we should treat fractions is basically just give the square root to the numerator and the square root to the denominator. Do the square root of each. Square root of 1 is just 1. Square root of 9 is 3, because 3 squared is 9. Same thing here, square root of 4 over the square root of 9. Square root of 4 is 2, square root of 9 is 3. We will break this up into 2 separate roots, one in the top, one in the bottom. Square root of 49 is 7, because 7 squared is 49. Square root of 25 is 5. Now here, we could do the square root of the top and the square root of the bottom. Let's look what that would look like. Square root of 64 over the square root of 4. Square root of 64 is 8, because 8 squared is 64. Square root of 4 is 2. But look, we have 8 over 2. This can actually be simplified to be 4. Another option here would have been to simplify inside first. If we do 64 divided by 4, we actually get 16 inside there. And then the square root of 16 is, of course, 4. Now, square root of 8 here, can you think of a number that when you square it, you get 8? Well, it's not 2 because 2 squared is 4. It's not 3 because 3 squared is 9. This is actually pretty weird. If we type this into the calculator, it would be a pretty weird decimal. So for now, I'm just going to say it's some decimal. I'll just say it's some decimal. Same thing here. We can't think of a number that when we square it, we get 20. So I'm just going to say it's some decimal. I'm not too concerned about it right now. But I'm wondering, what would it look like? Square root of 8. What would it be as a decimal? Would it be like 4 point something, 2 point something, 3 point something? Do you have an idea about that? The way that I would make my decision is this. I would look at 8, and I would say that 8, it's somewhere in between 9 and 4. Why do I pick 9 and 4? Well, I picked 9 and 4 because I know the square root of 9 and 4. And so I'll do the square root of all of them. The square root of 4 is 2. Here, you know what? I'm going to say that these are less than. I don't know what the square root of 8 is. I'm just going to leave it. And this is less than, okay, square root of 9 is 3. So what this is telling me is that the square root of 8 is something in between 2 and 3. I'm going to say it's between 2 and 3. Same thing here for 20. 20, well, what numbers is that between that we know the square root of? Just thinking about 20s, I know it's between, 25 I know the square root of. And 16 I know the square root of. That's just a little bit below 20. So if I do the square root of all of these, square root of 16 is 4. I don't know the square root of 20. Square root of 25 is 5. So I'm going to say square root of 20 is somewhere in between 4 and 5. Think about those. Think about the numbers you know the square root of, and complete those here. Just think about what two integers does the square root, each of these square roots fall between. Now, we can mix in some variables here. The square root of y squared, that is a little bit weird, but let's ask this question. What would I have to square to get y squared? Well, this is a little bit weird, right? I think I like this one better. What would I have to square in order to get x to the 6th? Now here, what do I square to get y squared? I mean, it's just y, right? Well, therefore, the square root of y squared is just y. Now, what would I have to square here to get x to the 6th? Well, I think it's going to be x squared. Okay, that's not x to the 6th. What would this have to be? This would actually have to have an exponent itself, so that when we square it, we get x to the 6th. Do you know what that would be? It would be 3. Remember, our rule is x to the 3rd squared. We multiply those. So I'm going to say that the square root of x to the 6th is actually x to the 3rd. What about here? Square root of x to the 18th. What would I have to square to get x to the 18th? Well, I think it would be x. Now, I know that these have to multiply to get 18. So I'm going to say that this is going to be 9 because 9 times 2 is 18. I'm going to say that the square root here is x to the 9th. Same thing here. Let's square it because it is a square root. What would I have to square in order to get z to the 28th? It would be z to some power, and that power, when I multiply by 2, it should be 28. I'm going to say that that's 14 because 14 times 2 is 28. Now you might see a pattern here, right? How to go from z to the 28th, the square root of z to the 28th to z to the 14th, 18 to 9. I think you can see a pattern there. Let's see. Now this one here, we're going to combine a lot of these things. Square root of 25, x to the 12th. y to the fourth. Let's look at each one of these separately. Square root of 25. I can break this root up into a bunch of little square roots. Now the square root of 25 is 5. The square root of x to the 12th, that will be x to the 6th. And here, square root of y to the 4th, you have to say, what do I square in order to get y to the 4th? I believe that will be y squared. So the square root of all of this, square root of this right here is 5x to the 6th y squared. Let's do this again. Let's see, square root of 9, square root of x squared, square root of y to the 8th. Square root of 9 is 3. Square root of x squared is just x. Square root of y to the 8th is y to the 4th. Now I'll let you finish that one there. Now, some of these numbers don't have a square root, right? Square root of 12, we mentioned we can't find anything. We could find out what numbers it's in between as a decimal, but square root of 12. I do want to simplify them in a way. And this is kind of like, it's kind of like reducing a fraction. When we see a big number inside of a square root, we'd like to, in a sense, reduce it. And here's what we're going to do. What we're going to do is we're going to split 12 into two numbers. And then break them into separate roots, kind of like we did here. Okay, if we have things multiplied inside of a root, we can break it up. Now, if there was things added in a square root, we cannot break it up. Okay, we can only do that because it's all multiplied there. So what I want to do is break it up in a couple different ways. Let's see, 12, I can break this up with multiplication as 2 times 6. Or I could break it up as 3 times 4. Now here, if I broke this into two square roots, I would write square root of 2 times the square root of 6. Here I would write square root of 3 times the square root of 4. Which one of these looks like it's going to be more convenient to breaking this down? I would say this one here. We know the square root of 4. We don't know the square root of 3, but we do know the square root of 4. We don't know the square root of either one of these. So this doesn't really go anywhere. So I don't like this. I prefer this. Now this says the square root of 3 times square root of 4 is 2. I'm going to finally write this as 2 square root 3. That's how I like to write it. Kind of like as if I would write 2x or something. This 2 square root of 3 is actually a simplified version of square root of 12. And whenever we see a number inside there that's a little bit big, we should think about doing this. Square root of 75. I want to break this up with multiplication. Can you think of two numbers that would be convenient to break it up with? What I'm thinking first is, how about 5 and 15? 5 times 15 is 75, actually. Another way to break this up would be to do 25 times 3. Those multiply to be 75. And I could break it up like this. Now, do we know the square root of 5 or the square root of 15? We do not. So I'm going to say that's not going to be helpful for us, but this is, right? We know the square root of 25 is 5. I'm just going to attach the square root of 3 there. It's finished. I've simplified the square root of 75 to this. Think about how to break this up in a way that's going to be helpful. And the way that I always say it is this, now that we've seen these. You should break it up into two numbers using multiplication, two numbers, one of which you know the square root of. So if you're thinking here that the square root of 45 breaks into 15 and 3, that is not helpful for us. This actually the most helpful way of breaking this up is as 9 and 5. So that's the square root of 9 times the square root of 5, and the square root of 9 is 3. I'm going to leave a couple of these for you to do on your own. But this one right here, square root of 48. We need to split it up into two numbers one of which we know the square root of. Now there's a couple ways of doing this. One way would be to break it up into 4 times 12. 4 times 12 is 48, and we know the square root of 4. What this would become is, okay, square root of 4 times the square root of 12, and then 4 is 2. Let me do it another way. How about if I use 16 times 3? 16 is a good number. We know the square root of it. So I say the square root of 16 times the square root of 3. Square root of 16 is actually 4. So it seems like I got two different answers, but they're actually the same answer. But which one's better? Well, I would say just like when we break down or reduce a fraction, we want to always reduce by the largest number, or else we're going to have to do the reducing multiple times. And that's actually the case here. This number here is too big. It can actually be broken down more. And here's how it can be broken up. 12 can be broken up into 4 and 3, 4 times 3. So what I'm going to do is I'm going to break this up now into square root of 4 times the square root of 3. I know the square root of 4 as 2. And 2 times 2 is 4. Do you see how I finally get the same answers? We want to take it down until the number inside of the square root is the smallest possible. That's going to work here for 72 also. There's a couple ways to do this. We could either break it up as square root of 9, the square root of 8, because we know the square root of 9. The way that I really break this up is I think about the numbers I know the square root of. 9, 16, 25, 4, 36, 49, 64. I think about those and see if they divide into there. I'm not even wondering really about numbers like 5, 7. Not really wondering so much about that. I'm wondering 4, 9, 16, 25, 36, 49. I'm looking at those numbers only. So this works, right? Square root of 9 is 3. I have 8. Can 8 be broken down more into something we know the square root of? It can. This can break up into 4 times 2. And finally, square root of 4 is 2. 3 times 2 is 6. But what we could have done also, without doing so many steps, this breaks down actually into 36 times 2. And the square root of 36 is just simply 6. And I'll attach the root 2 there. So go ahead and work through these yourself. What can you break these up into? And you want to split it into a number that you know the square root of. The numbers that I listed to you earlier. Check the completed notes for the solutions there. Now, what if we combine one of these numbers that we don't know the square root of with variables, right? What I always like to do is I like to break the number off, give it its own square root, and then give the variable its own square root. 18. How can 18 be broken up in a convenient way? How about it can break into the square root of 9 times the square root of 2, because I know the square root of 9. And I'll leave this here. Square root of 9 is 3. Square root of 2, I'm just going to leave it as it is. The square root of x to the 6th, if you didn't pick up on it earlier, really all we're doing is dividing the power by 2. So it's going to be x to the 3rd. So typically, we're going to write the root at the very end of the problem, or end of this expression here, like this. Right? How about here? Again, I'm going to break this up as give 28 its own root, and then the n to the 8th its own root. 28 is not a very big number, can't be divided by 9, but it can be divided by 4. Right? We can break this up into 4 times 7. Square root of 4 is 2. Square root of 7, I'm going to leave it as it is. Square root of n to the 8th is n to the 4th. And I'm just going to rewrite it in this order. 2n to the 4th, square root of 7 at the end. Again, check the completed notes for all the ones that I did not do on this page.